Hey, good evening, everyone. Welcome to O-Level Physics lesson. My name is Mr. Chu. Today is 6th of February, and we're going to start the topic on kinematics. Okay, so before I begin, can the participants share with me what do you understand by kinematics? Okay, can you just tell me maybe in a sentence or in a few words, what do you understand by kinematics? Okay, Ray Hong, Siren, and Yishen. Okay, Ray Hong and Yishen, can you hear me? Because Siren say you cannot hear anything. Okay, Siren just went out. Okay, Yishen, very good. Okay, so let me just share with you. When you see the word kinematics, okay, it is actually the study of motion. So anything got to do with motion, whether is it in motion or not in motion, anything that got to do with moving and not moving, okay, this is covered under the topic of kinematics. Is that clear? Okay, so before we talk about kinematics, okay, let me share with you the syllabus. Okay, so kinematics is part of this branch called Newtonian mechanics. Okay, so everything that we're going to learn, like kinematics, dynamics, and so on, is all under this branch of Newtonian mechanics. Okay, basically these are whole few topics. Okay, let me share with you the topics. Can you see here? Section number 2, Newtonian mechanics. So this is a branch of physics, okay, that got to do with forces. Okay, forces and yeah. So can you see here? Kinematics, dynamics, turning effect of forces, pressure, and energy. So these 5 topics will be all under under the branch of Newtonian mechanics. So a lot of things are based on what Sir Isaac Newton has discovered. A lot of things is all based on the Newton's law. Okay, do you all know who is Sir Isaac Newton? Okay, tell me yes or no. Give me a yes or no reaction. Okay, so Ray Hong know who is Isaac Newton. Okay, Yishan knows who is Newton. Siren, can you hear me now? Okay, very good. Okay, so let me share with you something. What Newton has discovered, okay, is not correct. I repeat myself again. So what you're going to learn in these few topics are actually not correct. Okay, but for everyday practical purposes, it's still okay. Okay, because as things starts to move very fast or things start to get very small, okay, Newtonian mechanics doesn't actually apply. Okay, that is where Einstein and the other scientists comes in. Okay, but for everyday purposes, talking about how fast a plane move, okay, how things walk, okay, it's all okay. Okay, so what we're going to learn now is all applicable. Okay, but just let me share with you, it's not 100% correct. Okay, but so for everyday stuff, okay, what we're going to learn in the second branch is still applicable. Okay, so what is Newtonian physics? Okay, Newtonian mechanics. Okay, so this is mechanics is a branch of physics that got to study, it's a deal with the study of motion and its causes and so on. Okay, and the greatest contribution to mechanics is by Sir Isaac Newton. Okay, So he actually developed the 3 laws of motion. We're going to learn that in chapter 3. Okay, we also are going to learn his law of universal gravitation. Yeah. And that is basically what Newtonian mechanics is about. Basically based on what Newton has developed, okay, during his time. Okay, so let's talk about kinematics. Okay, so I mentioned just now, kinematics actually is the study of motion. Okay, anything that got to do with moving, not moving, okay, we will need to talk about it over here. So kinematics is a study of motion. So we will talk about speed, velocity, acceleration. We need to know how to analyze all the graph. Okay, so this topic is very conceptual. Okay, I do not require you all to remember or memorize. I just hope that you all can listen to me by understanding. Okay, the whole topic will be very easy for you. Okay, and the last subtopic of this kinematic is free fall. Okay, so these are the topics that you're going to learn. Okay, I'm going to go through today. Okay, hold on for a while. Okay, so let me start about the first thing. Okay, the first thing all of you all need to know, okay, is the term distance and displacement. Okay, do you all remember in chapter 1, okay, we talk about scalar and vector. Okay, so distance is the scalar form of distance. Okay, whereas displacement, okay, basically just remember that distance and displacement are the same thing. Just that distance is a scalar, there's no direction involved, whereas displacement has a direction involved. Is that clear? Okay, how many of you feel that this word is hard to understand? If you think that it's hard to understand, give me a yes reaction. If you think it's okay, give me a no reaction. So I want to know how much you understand this word. Okay, so Rui Ho understand displacement very well. How about Siren and Yishan? Do you understand displacement? Or are you all confused about this word? Why are we learning the word displacement? Can I have some response? Siren and Yishan, can you share with me some response? Or you can type out something. Okay, so let me use, okay, this word will come out quite often in physics. Okay, and then if you don't understand this word, you might be in trouble. Okay, so do you remember in primary school when we learn how to find a mass of an odd-shaped object? Sorry, the volume of an odd-shaped object. Do you remember how do you actually find the volume of something that is odd-shaped? Because something that's regular shape, you can use mathematical formula like the volume of a cube, volume of cylinder. You learned that in the lower set. Okay, so how about for odd shape item like a rock? It's not a perfect sphere. How do you actually find the volume of a rock? Do you all remember how? Okay, I still not getting response. Can I get a bit more response from you all so that I know to go faster or slower? Okay, do you all remember, have you heard of this with displacement can experiment? So basically, okay, in a can, okay, maybe there is a can something like that. Let me show you. Okay, if there is a, yeah, something like a can like this, you fill up all the way to the brim. Okay, this is not very nice. Hold on, hold on, Okay, have you seen this experiment before? Okay, you fill the item to the brim. Okay, you fill it with the water to the brim. And then when you fully submerge your rock. Okay, you fully submerge your rock. The rock will replace the volume of some of the water. Am I right to say that? Okay, so whatever water that comes out in this measuring cylinder will be the volume of this odd-shaped item. So this is called a displacement can experiment. Basically, you're trying to displace the water, okay, to determine the volume of this. Okay, so what does displacement mean? It means that when there is nothing happen, it is at the original place. So displacement actually means how far or how much are they displaced. So for example, if you're at this point here, okay, then you move around, you move to here, okay, to this point, Y. Okay, so you're no longer at X, you're being displaced. Okay, so basically displacement will be this direct distance. You are being displaced by this distance at this direction. Are y'all clear about this? Whereas the blue curve is the distance you make to reach Y. Okay, to reach Y. Okay, the blue color path is the distance. It doesn't care about which direction you're moving, but it's the distance that you actually made to move to Y. Whereas displacement is how far you're being displaced from the original position. So this direct distance is the displacement of you. Okay, so the magnitude is this length, the red color length. Then there's a direction, maybe to the northeast east. Okay, the northeast east is the direction. Okay, so did I help you understand the meaning of displacement now? Is it a bit better? Because you're going to hear a lot of displacement in future. Okay. So are you all clear about what is distance and displacement now? Okay, so before we move on, can you all tell me what is the SI unit of both distance and displacement? Okay, they're the same thing, right? So they should have they're almost the same thing. Okay, so they should have the same SI unit. So can you tell me what is the SI unit of distance and displacement? Okay, Ray Hong, well done. Okay, hello, Brian. Okay, very good. For Ray Hong and Siren, you got the correct SI unit, the unit of distance and displacement. How about for Yishen? Hello, Brian, you can hear me? Please on your camera, please. Okay, and before I continue, let me share with you the short form for distance, okay? The short form for distance is D. The short form for displacement is S. Okay, so can you remember that? Okay, then for both of them, the unit is meter. Clear? Okay, Yishen, displacement is the same meaning as distance. Okay, so displacement, the only thing different is that displacement is a vector, it has a direction. Okay, so your unit for displacement is incorrect. Okay, Brian and Yishan, can both of you on your camera? I don't need me to explain one more time. Okay, so the next two things I'm going to talk about will be, okay, you learn this in primary school. The short form for speed is S. Okay, so speed is, basically speed is, the meaning of speed is the rate of change of distance. Okay, the definition of speed is the rate of change of distance. Is that clear? Whereas the definition of the next thing you're going to learn is velocity. The short form is V. Okay, so velocity, the definition that you need to remember is the rate of change of displacement. Okay, I'm going to say this many times. Okay, because it's very similar, but you may have heard it only the first time. So let me just share with you what's the meaning of. Okay, what's the definition of velocity and displacement? Okay, so in primary school, you all have learned this thing. Speed is equal to distance over time. Okay, do you all remember that? Okay, so that's a formula of speed. Speed is distance over time. So basically, in 1 second, if you can move very far, okay, your speed will be very high, you're moving very fast. Can you imagine that based on this formula? Or if you can cover 1 meter in a very short time, you're moving very fast, so your speed is high. Okay, so the greater the distance you can cover in a shorter time, you have a higher speed. So you're moving very fast. Okay, so that is the meaning of speed. Okay, likewise, velocity have the same formula. V is equal to S over T. And this S here means displacement, not speed. This S is displacement. So basically, speed and velocity has the same formula. Okay, just that. What's the difference? The difference is this is distance and this is displacement. Okay, so I will share with you another new thing. Can you see the formula here? The formula here, both of them have a denominator of T. Can you see the orange color T? So when you see a denominator of T, okay, when you see a denominator of T, from now on, okay, from now on, all your definition will be, for example, in this case, speed is the rate of change of something. Okay, so the key thing that I want you to remember is when you see divide by T, okay, divide by T, your definition will be the rate of change of something. So change of what? The red color one on top. Is that clear? Are y'all clear about what I'm trying to tell you? Because I do not want you to memorize all the rate of change of the quantity definition. So whenever you remember, if there's a formula that is divided by T, your definition will be speed is this one, the blue color. Speed is the divided by T will be rate of change of the red color quantity above. So it's a rate of change of what? Of distance. Okay, so this is something that I want you all to remember today. Okay, because this is something that's going to happen a lot. A lot of physics formula will be divided by T. And there's a lot of quantity that you need to remember. Okay, so if your quantity is divided by T, all you need to remember is rate of change of whatever's on top. Is that clear? So now, just to practice, can you all tell me, type it out in your chat. Velocity is what? Okay, what is the definition of velocity? This is something that you all need to memorize. Okay, so velocity is the rate of what? So can you all please write down? Brian, Ray Hong, Siren, and Yishen. Okay, Brian, well done. How about the rest of you? So can you see what I'm trying to do here? I do not want you to memorize the definition. I want you to understand every formula that you see that's divided by T, you will get the definition here. Okay, Ray Hong, very good. So you understand what I'm doing here? So velocity is the rate of change of displacement. Okay, you understand now? Rate of change because of the divide by t. Okay, what other divide by t formula do you all know? Up to now. Okay, for 14, 15-year-old you, what other formula that you know is divide by t? Okay, I give you a few more formula. Then you make a guess what is the definition? Because I will teach you all the generic meaning. Okay, so I'm going to give you a few more formula. So you're going to tell me whether you understand what's the definition. Let me see what other definition are there. Okay, how about this? Um, Power is equal to energy over time. Okay, so can you just make a guess? If I tell you to define power, okay, what will be the definition of power? Okay, so Ray Hong, you share your answer with everybody. Then you see whether everybody get the idea. Okay, it's not the exact correct, but if you write something like this, it's fine. Okay, so the definition of power. Okay, the definition of power is a rate of energy conversion. Is that clear? So can you see the pattern here? Can you see the pattern here? When you see divide by time, you will use the word rate of something. Clear? I give another example. Okay, how about this example? Current, I is current, is equal to charge over time. Okay, current is equal to charge over time. So can you tell me what is the definition of current? Current is what? Okay, so you see down here, there's divide by T. So divide by T. So you must say the word what? What's the word you must write? Current is the rate of what? Okay, rate of flow of electrical charge. Is that clear? Okay, so you all understand what I'm trying to help you. Okay, whenever you see a formula that is divide by T, okay, divide by T, divide by T, and divide by T, you need to remember that the definition will be is always the rate, because divide by T means rate. Okay, so current is the rate of flow of electrical charge. Power is the rate of energy conversion. Okay, speed is the rate of change of distance. Velocity is the rate of change of displacement. Is that clear? Now, let's move on. I'm going to share with you a new quantity that you're going to learn. Okay, the new quantity I'm going to introduce to you is called acceleration. The formula is meter per second square. Okay, so acceleration, okay, the formula of acceleration is v minus u over t. Okay, can you see a pattern here? Same thing, you will see that there is a divide by t here. Okay, what is v? V is velocity. What is u? U is also velocity. So v minus u basically means change of velocity. V is your final velocity and u is your initial velocity. So at first, your velocity is 10. Make sure your first velocity is 10, your final velocity is 20. So your velocity has increased by 10. So this v minus u is change of velocity. So now, based on what I've taught you about divide by t is rate. So can you make a guess? What is the definition of acceleration? Okay, all of you make a guess. What is the definition of acceleration? Okay, Brian, well done. How about the rest of you? Okay, Rui Hong, well done. Yixuan, very good. Siren, you're the last one. So acceleration, can you see divide by t is the rate. Okay, divide by t means rate. Rate of what? How the velocity changes. Okay, so it's a rate of change of velocity. Okay, so previously, okay, your teacher had taught you all about speed, velocity, and acceleration by now. Am I right? And all of you are expected to remember the definition. As you can see here, you must know the definition. Okay, you also must know the definition of acceleration. Okay, so you need to know all these definition. And because you all know the formula, okay, you all know the formula, which is down here. Okay, these are the formulas. From the formulas, you can actually derive the definition. Okay, so whenever you see divide by t, as I highlighted by the orange highlighter, it always means rate of, and rate of. Is that clear? So current is also the rate of flow of charge because divide by t. Power is energy over time. So divide by t is rate of. So are you clear about this thing? Because you're going to learn a lot of rate of formula. So instead of memorizing these 5 definitions, if you understand, whenever you see divide by t, your definition is rate of something. That's what you need to write in exam. Okay, am I able to help you understand this so far? All okay? Okay, if you understand, if it's helpful, give me a yes reaction. If you already know, give me a no reaction. Okay, so I'm going to remove everything here. So you understand all the definition now? Okay, so let me go back to the definition of speed. Okay, so all of you need to know speed. Okay, let me write down. Okay, now I'm going to write down in the short form. Speed is equal to distance over time. Okay, velocity is equal to displacement over time. So your definition will be speed is the rate of change of distance. Okay, then velocity is the rate of change of displacement. Okay, so this is the definition that you all need to remember. Okay, then you also need to remember another different another different definition. Okay, speed and average speed is different thing. Okay, speed and average speed is different thing. Okay, speed, as you can see over here, is distance over time. So what is average speed? Okay, so you all need to be clear that there's a different definition. Average speed is equal to total distance traveled over total time taken. So what's the difference between these two? They look the same to me. Okay, because you can see from the formula, speed is equal distance over time. In the second formula, you also see speed is equal distance over time. But the difference is this. Okay, there's a word average here. Okay, when you see a word average here, you need to add the total and the total inside your formula. Okay, so can you all please remember, when you see average speed, you learn this in your primary school, correct? You learn this also in lower secondary mathematics. Okay, average speed will be the total distance over total time. Okay, so this formula you all need to take note. When you write down average, I want to see the word total on the formula. Okay, up to now, any question? Is that clear? Okay, I will go through the rest of this in a while. Let me just give you a bit more concept. Okay, the way I always teach my student. Okay, so you look at this whiteboard here. There are different level. So there's level 0, level 1, level 2, okay, level 3, level 4, and so on. Okay, so let me start with a certain level. Okay, so level 0, can I put it as a point? A point in a place is called a point. When the point actually moves from one place to the other, we call it a distance. Is that clear? Okay, so distance is actually level 1. It's actually one level higher than a point. Okay, a point is just a point. Distance is the distance between 2 points. Okay, this is the point. Is that clear? So a point is very basic. It's just a point. Distance is the length between 2 points. Up to here, any question? Okay, let me not use distance. Let me use the vector definition. Okay, I will use displacement. Okay, then level 2, I just want you to know, level 2 is the next level, higher level. Okay, we call this the velocity. Clear? Velocity. And then when we go up another level, level 3, we call it the acceleration. Can? Okay, up to now, have y'all learned acceleration in school? Yes or no? Okay, Brian, yes. Ray Hall, Siren, and Yishan, have y'all learned acceleration in school? Siren, okay, Siren in Sec 2, that's why I haven't learned. Okay, never mind. Ray Hong and Yishan, have you learned? Ray Hong, okay. Brian and Ray Hong, do you understand? And Yishan, the three of you, do you understand what does acceleration mean? Or you just memorize the definition, or rate or change of velocity? Okay, do you actually understand exactly what does acceleration mean? Okay, if you understand exactly, okay, Brian was telling me if the car speed up over time, that accelerate. Okay, very good. That's a very good definition, but you understand what it means? You understand what does it mean in real life? Not just using a definition. So Brian doesn't understand. Okay, let me go back. Now, do all of you understand displacement? Okay, yes or no? Give me a reaction. Do all of you understand displacement now? Basically, it's just the distance between 2 points. Okay, Brian say yes. How about Ray Hong, Siren, and Yishan? Do all of you understand displacement or distance? Okay, Yishan, thank you. Okay, Ray Hong, thank you. Siren, you understand the meaning of displacement or distance? The idea, the idea. Okay, very good. How about velocity and speed? Are you able to understand what's the meaning of velocity and speed? Basically, how fast the things are moving, correct? So are you able to understand the meaning of this? What does this mean? How fast, how fast something is moving. Okay, see you. Thank you. Ray Hong, Brian, and Yishen, you understand now? Okay, so acceleration is a bit hard to understand at first. Okay, then let me try to explain a bit later. The next thing about acceleration that you don't need to learn is called jerk. Okay, so after level 3, there's level 4. After level 4, there's level 5. Okay, so in O-level physics, or even in A-level, okay, you only need to know level 1, 2, and 3. Is that clear? Okay, there's no need for you to learn everything. So I'm just trying to tell you all, okay, here I'm just trying to tell you that there are different levels. Okay, you need to know just level 1, level 2, and level 3. Is that clear? Okay, so this whiteboard, I'm just trying to tell you that there's actually more level after 3. After 3, there will be jerk. After 4 will be something else. Okay, so there are more levels after this. Okay, mathematically, you can go on forever. Okay, what it means might not make sense after that. Okay, jerk, maybe you can still make a bit of sense if you try to imagine. Okay, but now I'm going to tell you all what is the meaning of acceleration. Okay, so before I continue, to find, okay, so can you see down here, displacement, velocity, acceleration. Can I draw a graph? Can I draw a graph? Can I draw a displacement time graph? Okay, let me show you an example of what I'm trying to say. Can I draw a graph? Okay, wait. Cubic. Can I draw a graph like this? The y-axis is displacement. The x-axis is time. Can I do that? Likewise, can I also draw a y-axis as velocity, and then the x-axis is time? Okay, if you are not very confident of the word displacement and velocity, for now, just think of this as distance and speed. And the idea is the same for now. Okay, then can I also draw another graph? Okay, where the y-axis is acceleration, and then the x-axis is time. Can? Okay, so what am I going to show you here? So what I'm going to show you is this. Displacement is at level 1, or distance is at level 1. Speed and velocity is at level 2. The higher the level, the more abstract it is. Okay, the more abstract it is. And in a graph, can we draw a graph like this? Go up, then go up. Then I draw another graph. Can I draw something like this? Can I draw the same graph for all 3 of them? Okay. So let me try to explain to you what am I trying to do here. Okay, so can you see? I can draw the same graph for these 3 graphs, but the y-axis are all different. The first one on the left is the displacement time graph. Okay, if you want to make it easier, just think of it as distance time graph. Okay, so we go very, very basic. In this example, you are moving. Okay, moving until here, you stop moving because your distance remains the same. Am I right to say that? So can you understand this graph? You are moving. Then reach a point where you stop moving. Can you understand now? This is a distant time graph. Okay, for the same graph here, can you see? Your speed at first is 0. Your speed or velocity at first is 0. Then as you move, your speed increases. Until which point, your speed remains the same. Okay, your speed or velocity remains the same. So this second graph is like this. Okay, the same thing, we can talk about the third one. Your acceleration is 0 at first. Then you accelerate, the value becomes higher and higher. Then reach a point where the acceleration is the same. Okay, so now I want to explain certain thing to you all. how to describe a graph. For all three graphs, when they are flat, you just need to say that. In the first example, when it's flat, you just say that the displacement is constant. Clear? Now, in the second graph, here is flat. So can I say that the velocity is constant? Okay, I want you to remember this. Then the third graph will not be tested. You will not be shown an acceleration graph. Okay, but just for practice, when you see an acceleration graph where the value is the same, you can say that the acceleration is constant. Okay, this one able to describe? Okay, basically, I want you to understand how to see a graph. Okay, next thing. Here, your displacement is going up. So can you say that your displacement is increasing? Can you say that? Your displacement is increasing. Then for the second graph, your velocity is increasing. Your third graph, your acceleration is increasing. So are you able to use these simple words to explain the graph? Okay, if you understand, give me a yes reaction. If you are confused, give me a no reaction. Brian, you okay? Okay, very good. Okay, now you compare this one. This is increasing. Let me draw another graph. The red color one. This is also increasing. Okay, can you see on all three graphs, the red color graph is also increasing. Can you see that? The y value become higher and higher over time. Okay, for the velocity time graph, the velocity is also increasing. Then for the acceleration, it's also increasing. So what's the difference between the blue and the red? They are both increasing. Okay, they are both increasing. But what's the difference? What's the difference between the blue and the red graph? They are both increasing, but what's the difference? Okay, so can you see? For the blue graph, the distance is going up at a similar value every second. Correct? Every unit of time is going up at the same rate. Okay, velocity here. Every second, every unit of time, the velocity is increasing at the same value. Then for acceleration here, for every unit of time is increasing at the same value. So we call this increasing at the same rate or a constant rate. The rate is constant. Understand? The rate of increase is constant. Okay, so for example, maybe for the velocity time graph, after 1 second, your velocity is 10 meters per second. After another second, your velocity becomes 20 meters per second. So the increase is constant. The rate of increase is constant. Is that clear? Okay, same thing here. Or when it's flat, the rate of increase is 0. It doesn't increase at all. So the rate of increase is 0. So when here, the rate of increase of the velocity is also 0. And therefore here is also 0. So this rate, what is the mathematical term that you learn in mathematics? That can we describe the rate? If this rate is very steep or less steep, what's the term we use? Start with G. Anyone? Start with G. Okay, so basically you can see, I use another graph. Yeah, I draw another graph. Can you see the blue and the black? Both are increasing at the same rate. But what's the difference? Which one increase faster? The black or the blue one? Which one increase faster? The black or the blue one? How do you know which one increase faster? The black is steeper, correct? Okay, very good, Ishan. Black is steeper because it has a greater what? What's the word? Psi G. You learn this in Sec 2, mathematics. Okay, well done, Ishan. Well done, Brian. How about Rui Hong and Siren? Which one move faster? The black or the blue? Okay, Rui Hong, correct. Siren, correct. Okay, so all of you can tell me the black move faster, the blue move slower. Yes? All of you can see from this graph. Can all of you tell me the speed of the black, is it the same throughout or is it different? Is the speed the same or is it different? So can you tell me the black color graph? Is the speed throughout from the bottom to the top here, is it constant or changing? Okay, Siren say constant, Rui Hong say constant. How about Yishan and Brian? Brian don't know. Okay, can you see down here? I'll give another example. The black color graph will reach this distance, maybe this distance is 5, in a shorter time, correct? But the blue graph will take a longer time to reach 5. So which one is moving faster? The black or the blue? Okay, the black is moving faster. So how you tell? Okay, so the thing to tell is, okay, some of you have told me, to see which one is moving faster in the displacement time graph, you look at the gradient. Okay, so you have learned gradient. Gradient is rise over run, correct? Is rise over run. The bigger the rise over a smaller run, your gradient is bigger. So in the displacement time graph, can you see? The gradient is the same throughout. So the gradient is the same throughout. The change in displacement is the same throughout. Meaning, every 1 second you move 2 steps. Every 1 second you move 2 steps. Every 1 second you move 2 steps. So is your speed the same? Okay, is your speed the same? Because every 1 second you move 2 steps. So is your speed the same? Okay, Brian say yes. How about the rest of you? Can you be a bit more reactive to me? Okay, Siren say yes. Rui Hong and Yishan, are you all confused now? Okay, so can you look at this graph? For the black graph, every second, maybe you will take 2 steps. But in the blue graph, can you see? Every second, you take 1 step. But every second, you take 1 step. You are very consistent. You are taking 1 step every second. Whereas for the black graph, you are taking 2 steps every second. So you are moving faster. Okay, so far? Okay, so what am I trying to show you here? In a displacement time graph, okay, in a displacement time graph, your gradient, the steeper the gradient, the faster you are moving. So this thing called fast, there's a term for it. It's called speed and velocity. Is that clear? Okay, the term that we are using here is speed and velocity. So are you convinced that the gradient of a displacement time graph give you the value of velocity? Are you convinced now? Can you give me a reaction, yes or no? Okay, thank you, Siren. Okay, thank you, Ray Hong. Thank you, Yishan. Thank you, Brian. Okay, so you're convinced that, okay, so level 1 is displacement. Level 2 is velocity, the speed. So are you convinced that in a level 1 graph, if you want to find a level 2 quantity, you find the gradient? Okay, so that is the concept I want you to remember. I repeat, okay, in a displacement time graph, the gradient will tell you the next level quantity, which is velocity. So in a displacement time graph, the gradient is the velocity. Are you all clear? So in the velocity time graph, the gradient is the acceleration. Is that clear? Okay, so in the acceleration time graph, the gradient gives you the quantity called jerk. Okay, I don't need you all to memorize jerk lah, but I'm giving you all this idea. There are different levels. As you go up the level, you find the gradient. Are you able to remember this concept? Yes or no? Okay. Likewise, if I want to find the quantity at the lower level, I find the area under the graph. So for example, you look at acceleration here. If I want to find the velocity in this graph, how do I find? Okay, I actually try to find by finding the area under the graph. So this area under the graph here is the velocity of this flat line. Okay, you don't need to know this because you don't need to know acceleration time graph. So I just try to tell you, in the velocity time graph, if you find the area under the graph, the area under the graph is the displacement. You go down one level. So can you all remember this? Okay, as you find the gradient, your level go up. As you find the area under the graph, your level goes down. So this is what I want you to remember. Okay, so far? Okay? Okay, then I'm going to talk a bit more. Okay, in A Max. Do you all learn additional mathematics? Okay, in A mathematics, in additional max, there's this study called calculus. You're going to learn that in the last topic in Sec 4. Okay, a big part of Sec 4, you're going to learn calculus. Okay, as you find the gradient, okay, as you find the gradient of things, what you are trying to do in calculus, in mathematics, and there's this word called differentiation. Okay, so I want you just to remember, because everything will be the similar pattern. Okay, so you differentiate a graph. You're just trying to find the gradient of the graph. You're able to find the next level quantity. Okay, that you're going to learn that in calculus. You're going to do a lot of formula, how to differentiate something. Okay, you're going to learn how to differentiate a graph, okay, the formula of a graph. Okay, once you differentiate something, you'll be able to find the gradient, the value. their value will be the next level quantity. Clear? Okay, then area under the graph in calculus is called integration. Okay, so you're going to learn these two words a lot in Sec 4 in your calculus of your additional mathematics. Okay, so if you have your additional mathematics textbook now, you look at the back. Okay, there is a lot of topics on differentiation and integration. Okay, so the mathematics teach you how to do it if you have a perfect graph. Okay, so now I'm just telling you all the concept. When you differentiate, you are just finding the gradient. So in Amex, you're just trying to use a method to use a calculation to calculate it. Is that clear? Because your graph may not be so nice, straight line. It could be curved and so on. Okay, so in calculus, they are able to do it using a method called differentiation. Okay, then for area under the graph, in calculus, in additional mathematics, you're going to learn integration. Okay, so they have a certain steps for you all to calculate the area under the graph. So for example, you see the red color graph. How are you going to find the area under this graph? That's what you're going to learn in Amex. Okay, for this straight line, you can find the area lah. It's a rectangle. The blue line, also easy. It's the area of the triangle. But how are you going to find the area under the red line? You're going to learn that in Amex. Okay, if you know the formula of this graph, okay, you will apply integration, you'll be able to find the area under the curve. Okay, so that's what you're going to learn in additional max, okay, in Sec 4. So I just try to tie in together so that you all see the big picture, what you all are doing, rather than looking at different things one at a time. Is that clear? So the main thing in this whiteboard that I'm trying to share with you is this. All you need to know is level 1 is displacement. Level 2 is velocity. Level 3 is acceleration. Okay, so in a displacement time graph, if you want to find the next level, the higher level quantity, you find a gradient in a displacement time graph. Same thing, in the velocity time graph, if you want to find the next level quantity called acceleration, you find the gradient. Is that clear? And then it goes on forever. But of course, as you go higher, it doesn't make sense. Okay, jerk still can make sense a bit. Now level 5, level 6, I don't think it makes sense anymore. Okay, but you can still calculate in mathematics, because in mathematics, there's no end. Okay, likewise, in a level 2 graph, velocity time graph, can I find a level 1 quantity? Yes. Okay, you do integration. In calculus, it's called integration. Okay, for now, the simple term is called area under the graph. Okay, so far? So the main thing I want you to remember, displacement, velocity, acceleration in this order. As you go from level 1 to level 2, you find the gradient. But you want to find level 3 from level 2, you find the gradient. As you go down, you find the area under the graph. Okay, so far? This idea, I just want you to remember today. Today, remember this. As you move up the level, you find the gradient. As you move down the level, you find area under the graph. That is the main concept I want you to remember today. Okay, lah. Understand? Understand, give me a clap. Don't understand, give me a no reaction. Okay, thank you, Brian. How about Ray Hong, Siren, and Yishen? Are y'all confused? Okay, so let me just clear the whiteboard. Okay, so we go to this syllabus. All these definition I haven't gone through yet. What is uniform acceleration, all these non-uniform, how to, okay, all these I haven't even talked about it yet. So, can we talk about F first? Okay, from a shape of a displacement time graph, can you tell when the body is at rest, moving with uniform velocity, and moving with non-uniform velocity? Okay, so let me talk about this now. So we're talking about displacement time graph. So let me draw the graph for you. So let me draw a graph. So this is a displacement time graph. Okay, so first of all, when it is at rest, how will it look like? When it's not moving, how will it look like? When your thing is not moving, would there be any displacement? Okay, so when it is not moving, okay, there's a few ways. It can be right from the start, you don't move. So you see, it's a straight line. Or you really move a bit, but you remain in that displacement. So these two black line is when your object is at rest. Can you see that? Your object is at rest. In your displacement time graph, it is not moving. Clear? Next thing, when it is not moving, do they have velocity? Okay, tell me in your feedback, in your reaction, is there velocity? If there's velocity, give me a yes reaction. If there's no velocity, give me a no reaction. Is there velocity in these two black graphs? Okay, thank you, Ray Hong. Thank you, Brian. Okay, Siren and Yishen, is there velocity? Okay, Siren, type out. Okay, so you know they are not moving, so there should be no speed, right? There be no velocity. So do you remember in the displacement time graph, how do you actually determine the next level? The next level is velocity. How can you determine the next level? What do? You find the what? What's the word to use? You find the start with G. To find the next level quantity, you find the gradient. So you look at these two graphs, the black graph. To find the velocity, you find the gradient. Can you see the gradient is, there's no gradient at all. So for these two graphs, the gradient is 0. Is that clear? In these two black graphs, the gradient is 0. So your conclusion is the velocity of these two items is 0 because the gradient is 0. Is that clear? Can? Now, let me give another example. Okay, so this is another example for a distance time graph. What's happening here? Every second, it has a same displacement. Every unit time, there's a same displacement. For example, like what I told you just now, every 1 second, it moves 1 step. Every 1 second, it moves 1 step. So the whole journey is the displacement uniform. Can you tell me, is the displacement uniform? Yes or no? Okay, thank you, Brian. How about the rest of you? Can you give me a reaction? Is the displacement uniform for this example? Okay, so the speed is the same. Are you all agree? Because every second you move only one step. So you're moving at the same speed. Okay, so in this is a displacement time graph. You need to know, okay, you want to find the velocity. Velocity is the next level. You find the gradient. So can you see over here? Throughout the black line, the gradient is uniform. The gradient doesn't change. The gradient is fixed. The gradient is constant. So can you conclude, okay, during the whole motion, your velocity, your next level, your velocity, your gradient, your next level velocity is constant, is uniform. Can you remember that? May not remember. Can you understand that? Okay, the gradient is uniform. So the next level is called what? Velocity. So the velocity is uniform. Can you see that? Understand? Okay, so the gradient is uniform. Your velocity is uniform. Okay, that's what I want to share with you. Okay, next. Next. How about like this? Can you see? At first, the first second, you take 1 step. Next second, take 2 steps. Next second, take 5 steps. Then next second, take 10 steps. What's happening here? What's happening here? Based on this drawing, can you tell that as you're moving over time, your steps you're taking is bigger and bigger? You're taking more and more steps. Okay, so what's happening here? Is your speed uniform? Yes or no? Okay, your speed is not uniform. Okay, so to find the speed, to find the velocity, what you need to do is to find the gradient. Can you see here? The gradient is like that at first. The gradient is like this. The gradient is like this. So can you see the gradient is increasing? The gradient is increasing. Then replace the word gradient with what? The next level is called what? It's called velocity. So can you say that the velocity is increasing? So when you see a shape like this, can you see the gradient? The gradient is increasing. So can you describe this as the velocity is increasing? It's increasing velocity. Okay, the velocity is not uniform. It is increasing. Understand what I'm trying to share with you? Okay, if you understand this, give me a yes reaction. Rui Hong and Yushen, okay? Okay, so this is one example of a non-uniform velocity. Okay, to be specific, this is called increasing velocity. Because the gradient is increasing, so the velocity is increasing. Understand? Okay, the next example, let me show you. How about like this? This kind of graph, how do you describe the motion? So the gradient is what? In this case, what's the gradient like? The gradient here is very steep, then become less steep, then here become even lesser steep. So the gradient is decreasing. Okay, so when the gradient is decreasing, the next level is called what? Velocity. So can I say that the velocity is decreasing? Understand now? Okay, so now let me just change the word. Let me just change the word. Instead of the word displacement, let me change the word to velocity. So now we're talking about the velocity. Now we're going to G. So we are talking about velocity time graph, but we go to this example first. We talk about this example first. At first, okay, let me just talk about the black graph. The black graph is going up, right? Correct? Can you see the black graph is going up? The black graph is going up. It means that the velocity is going up. Is that clear? The velocity is going up. Okay, so what is the gradient? The gradient is uniform or non-uniform. So for in this case, the gradient is non-uniform. So we are moving at a non-uniform gradient. Okay, in the velocity time graph, the gradient gives you the next level quantity. The next level quantity is called acceleration. So in this example, you say that the velocity is increasing. Okay, the velocity is going up, right? So it's increasing. Okay, with a decreasing acceleration. Are you all confused? Yeah, I write here. Velocity is decreasing, right? It's increasing. Can you see that? Velocity is increasing, right? Because it's going up, it's going up, velocity is going up, So velocity is increasing. Okay, with a decreasing acceleration. Okay, what does this mean? Acceleration is a gradient. Can you see at first the gradient is very steep, then become less steep and even lesser steep. So the gradient is decreasing. The decreasing gradient is a decreasing acceleration. Are you all okay? Or are you all more confused now? Okay, if you understand what I'm saying here, give me a yes reaction. If you don't understand what I'm saying, give me a no reaction. Okay, read hold and see whether you're okay. All right, so let me go back to the definition of acceleration. Acceleration is the rate of change of velocity. It's how fast your velocity change. So can you see here? Your velocity change very fast. So acceleration is high. Then at the third level, the third one, your velocity change little bit. Okay, so the change of velocity is low. So acceleration will be low. Okay, so here at first it has a high acceleration. So medium acceleration, low acceleration. So your acceleration is decreasing. Understand now? Okay, that is an example of a non-uniform acceleration. Okay, so the speed or the velocity is going up. It's moving faster and faster and faster. But at how fast is the rate? The rate is slowing down. Understand now? The rate is not slowing down. Okay, the word slowing down is a bad word. The rate is decreasing. The rate that the velocity is increasing is decreasing. Are you clear what I'm saying? What I'm trying to say? Okay, velocity is going up, right? So it's increasing. But the rate of its increase is decreasing. Okay, so the acceleration is decreasing. So, one example is like a rocket. At first, your rocket has a high acceleration. So you actually can go up very fast. Then as it actually reach a point where it doesn't increase its speed anymore, okay, your acceleration drop. So it's like in the car. We are in the car, you're not moving. Then your driver step onto the accelerator very hard. So your arm will be swing back. Okay, you have a very high acceleration at first. Then as the car increase the speed and become more and more stable, you're no longer pushing against your chair. So that is when your acceleration is not so high. So at first, when the speed of the car changed from 0 to 10 in a very short amount of time, it has a very high acceleration. So do you understand acceleration a bit based on your real life experience? Are you able to appreciate the understanding of acceleration now? Okay, if you understand acceleration, give me a yes reaction. Okay, so let me go through another example. Okay, another example. How about this example? Let me show you. The speed is also going up. Okay, the speed is also going up. Okay, your velocity is going up. Okay, but how do you describe this motion? How do you describe this motion? Is it moving with uniform velocity? Yes or no? Is the thing at rest? Okay, there is velocity, so it's not at rest. Is it moving with uniform velocity? Okay, no. Okay, so in this case, this not at rest, is not moving with uniform velocity. It's also not moving with a uniform acceleration. Okay, why do I say that? Okay, why do I say that? Because the gradient is increasing. Can you see the gradient is increasing? Okay, the gradient of this graph is increasing. So the gradient tells you the next level, which is the acceleration. So can you say that in this example, you can say that the velocity is increasing with an increasing acceleration. Means that the change in velocity is greater and greater over time. At first, you're moving, okay, one step. Okay, no, I cannot use the example. The step is I cannot use the example. So can you see? The increase in the velocity become higher and higher over time. So therefore, in this example, okay, the way you describe is velocity is increasing with an increasing acceleration. Are you clear about this? Because the gradient is increasing. So the gradient is increasing, your acceleration is increasing. Understand? Can? Okay, now we go back to the simple one. It's a bit cheap now. But the main idea I want you to understand is this. The gradient tells you the quantity of the next level. So velocity time graph, the gradient tells you the acceleration. Is that clear? In the displacement time graph, the gradient tells you the velocity. So I want you to remember that. Can? Okay, let's go through something very simple because we've been doing all the very not simple one. Okay, let me go through the simple one with you. Okay, when your object is not moving, basically it's just zero. Is that clear? When it's not moving, it should not have any velocity. It should be just zero. Okay, it'll be just zero. Clear? Now, when the thing is not moving, there is no velocity. And then can you look at the gradient of this? The gradient is also zero. So can I also say that the acceleration is zero as well? Can I say that? Okay, in this example, the velocity is zero. The acceleration is also zero because the gradient is zero. Is that clear? Is that clear? Understand? Okay, so in this example, the object is not moving because the velocity is zero. Then, now, next thing I want you to see. Can you see the area under the graph? Is there any area under the graph? Okay, there's no area under the graph. So the level below velocity is called what? Displacement. Okay, so the area under the graph is zero. The displacement is zero. Are you clear about this? Did I make you all understand this better? Okay, now how about if there is velocity like this? Is the thing moving? Tell me, is the thing moving? Yes or no? Is the object moving? Give me a reaction, yes or no. In this example, in this graph, is the object moving? Yes or no? Thank you, Yishan, you're correct. Brian and Siren, what do you think? Okay, Ray Hong, well done. Brian, well done. Siren, is the object moving when there is a flat velocity? Okay, very good. Okay, so all of you can imagine when it has a speed of, let's say, 1 meter per second. Okay, and the speed is constant. So the object is moving. Okay, it's moving, number one. Okay, then number two. Okay, what is the gradient here? The gradient of this is zero. So from this graph, can you say that the gradient is zero? So your acceleration is zero. Can you say that? Okay, so number one, you must say that, okay, the object is moving. Okay. Why? Because the velocity is uniform or constant. Okay, the velocity is uniform. There is a velocity value and it's uniform. And it's uniform, can you also conclude that the acceleration is zero? Because the gradient is zero. Okay, the gradient is zero, so the acceleration is zero. Then from this graph, can you tell what is the displacement? Okay, can you tell what's the displacement move? So for example, if it's moving at 2 meters per second, in 10 seconds. What's the distance move? So every second it moves 2 meters. So 10 seconds you move 20 meters. Am I right? So can you see from this graph? Can you see from this graph? If I were to find the area under the graph, okay, 2 times 10. Okay, area under the graph. So area under the graph is your displacement, which is 2 times 10, which is 20 meters. Does it make sense to you now? Okay, because it's moving 2 meters per second, every second is move 2 meters. So for 10 seconds, you move 20 meters. Does it make sense to you? The area under the graph gives you the lower level quantity, which is displacement. Is that clear? So today, did I help you open up your eyes? And now you can actually see a lot more things in the graph. Because I believe a lot of students, when teacher teach this topic, the eyes are still not open one. Okay, because you really need to understand, then you will able to see the whole thing. Then you have an aha moment. Okay, is it useful so far? Okay, so in this case, for a velocity time graph, if you can find the area under the graph, you'll be able to find the lower level quantity, in this case, displacement. And this displacement here is 20 meters. Clear so far? Can? Now, we'll give another example. We are very, very tired already. Can you feel my energy? Okay, so remember I told you all in the first lesson that when you go through this topic, I try to explain things by concept. So once you understand, there's actually little to memorize. Just need to understand will do. Okay, I hope that I can have achieved that. Okay, let's continue the last few example. Okay, so now we have the same velocity. Okay, now the graph, I'm going to draw a different graph. Let me show you. How about like this? This one means what? Can you see? The velocity is increasing, correct? What's the gradient? Is the gradient constant? Okay, so first thing first, you must say that the velocity is increasing because it's going up. That's one thing you can see from the graph. But increasing at what rate? Okay, can you see the gradient here is fixed all the way? It's fixed all the way. So the gradient is uniform. So it has a uniform acceleration. Is that clear? Meaning that every second, your velocity increase by the same amount. Can you see from this formula? Every second, your change of velocity is the same. It's constant. It's uniform. Okay, so if the gradient is uniform, your acceleration is uniform. Is that clear? Now, same thing. This is 10 seconds. This is 2 meters per second. In this whole motion, how much did the object move? Okay, how much did the object move? Okay, so another thing I want to share with you. This gradient, is it positive or negative? Can you tell me? Is this gradient positive or negative? Okay, so this gradient is positive, so you must say that this is a uniform positive acceleration. Is that clear? If it's going down, okay, if it's going down, you'll say that it's a negative acceleration. Okay, same thing for your displacement time graph. If your gradient is positive, your velocity is positive. In this case, your gradient is positive, your acceleration is positive. Is that clear? Okay, so if the gradient is positive, just need to change the word gradient to acceleration. That's all. Okay, your positive and uniform is all the same. Now, to find the displacement, okay, how much we move. Okay, all you need to do is to find a area under this graph. Is that clear? So area under the graph is your displacement. So how to find that? Is the area of the triangle. So in this example, your object will have moved 10 meters. Clear? So you can write down like this. Area under the graph. Okay, you can write down. In your exam, you write down displacement is equal to area under the graph. Okay, write down the formula. Area of triangle half times base times height. And therefore it's 10 meters. Okay, that's how you do to find the area, the displacement. So if you're in exam, you just write down displacement is equal to area under graph, because area under graph tells you the quantity of the lower level. So displacement is a lower level compared to velocity. So to find the lower level, you find area under the graph, and then you get the answer. Is that clear? Understand? So far, any question for me? Okay, so did I actually give you a different perspective on this topic? Okay, hopefully I did. And once you know this, it becomes very easy because you know the idea. Okay, let's go through one last example for this. Okay, how about if I have a graph like this? It's moving slower, correct? It's moving slower because your velocity is decreasing. Okay, so in this example, how do you describe the motion? You may say that this is a velocity is decreasing at a what rate? At a uniform negative gradient. Okay, so this is a uniform negative gradient. So you just need to change the word gradient to acceleration. Is that clear? Okay, let's practice. Let's practice. How do we find the acceleration of this? You look at this formula. The final speed, the final velocity is 0. I put 0. Initial speed here, the initial velocity is 2. So I put 2. Divided by the whole time is 10 seconds. Okay, so I get negative 0.4 meter per second square. So what does this value means? How do I make sense of this value? This value means that every second, your velocity dropped by 0.4 meter per second. I repeat myself again. This is the same as, this means that every second, your velocity decreased by 0.4 meter per second. That's what acceleration means. Okay? When the graph is going up, it will be every second, your velocity increased by 0.4 meter per second. Are you clear about this? Okay, so in this example, your velocity is decreasing. At what rate? At a uniform rate, at a negative rate. Okay, so you just need to change the gradient to acceleration. You just need to describe here negative uniform acceleration. Is that clear? Then to find the distance traveled, just need to find the area under the graph. Okay, find the area of the graph. Okay, same thing. Just need to write down displacement is equal to area under the graph. In this case, it's half times base times height. You will get 10 meters. Okay, so the displacement of the object of the body is area under this graph. And we calculate, you get 10 meters. Is that clear? So, what if the graph is curved? How do you find the area under the graph? Okay, that's where you learn your calculus in AMAX. Okay, when you go and use the formula of the graph, you can integrate to find the area under the graph. Okay, so if it's the graph is a curve, right? Okay, a curve very hard to find the area. You'll learn that in AMAX. Okay, in Sec 4 in your last topic. Is that clear? Okay. I spend a lot of energy on this topic. Can you feel the energy? Is it helpful to you? If it's helpful, give me a yes reaction. If it's not helpful, give me a no reaction. Do you all learn a lot compared to previously in school? Okay, so Did I help you understand the concept? Because once you understand the concept, there's nothing to remember. Do you realize? Once you understand the concept, okay, there's actually nothing to remember. Just it will be with you forever. Okay, before we go, I want to go through the last part, but let me just go through very quickly. We'll go through the notes next time. For part I, you need to know that whenever anything fall on Earth, anything that fall on Earth, it will not fall at a constant speed. It will fall at a constant acceleration. Okay, what does this mean? This means that anything that is falling on Earth, right? We don't talk about things like feather or your piece of paper. These are actually have a lot of air resistance. So we're assuming that there's very negligible air resistance. Every object will fall at an acceleration of 10 meters per second. What does 10 meters per second means? Okay, this one means every second your speed will increase by 10 meters per second. How does it look like in a graph? If I were to draw a velocity time graph, okay, every second you'll increase by 10. At 2, will be at 20. 3 seconds later, you'll be at 30. So this is how things will how the speed of things will increase when it fall on Earth. Every second, your speed increase by 10. So in 3 seconds, what's the distance covered? Can all of you go and calculate? In 3 seconds, okay, I'll tell you what. Can you calculate in 1 second what's the distance? In 2 seconds, what's the displacement? And in 3 seconds, what's the displacement? Can you all go and calculate now? 1 second, what's the displacement of the object? Okay, 10 times 1 times half. So are all of you convinced? In 1 second, your object will fall 5 meters. So if you jump out from level 2, you reach the ground in less than 1 second. Are you clear about this? Okay, because our level 2 could be just 3 meters. Okay, so can you see? 1 second, your speed will increase to 10 meters per second, and your distance traveled will be 5 meters. Okay, 5 meters. How about 2 seconds? What's the area under the graph of 2 seconds? 20 times 2 times half. What's the answer? Okay, it'll be 20 meters. Correct? So can you see? How high must you be? Then to reach, then when you drop, you fall from the sky, you reach the ground in 2 seconds. It will be 20 meters high. How about 3 seconds? So 3 times 30 times half. What's the answer? Okay, 45 meters. So you understand what I'm trying to show here? Okay, 45 meters. If each level is just 3 meters, for example, from the floor to the ceiling is 3 meters. If you were to drop something from the 15th story, you reach the ground in 3 seconds. Are you clear about that? You understand what I'm trying to say? Because every second, your speed increase by 10 meters per second. So by the time you reach 3 seconds, you're already traveling at 30 meters per second. So every second is 30 meters. So therefore, if you're at a 15th story, you drop a book, you should reach the ground in 3 seconds. Understand what I'm trying to say so far? Okay, so acceleration due to free fall is 10 meters per second square. That's how strong our gravity is. So can you imagine what's the acceleration of free fall when you're at the moon? Is it higher or lower? If you're at Saturn, Jupiter, or even the sun. Yeah, so things that super big, has super big gravity, your acceleration due to free fall will be much bigger. So it'll be falling much faster. Okay, so today's lesson, did I help you understand the whole topic concept? The concept, the whole topic. Basically, divide by time is rate. Okay, when you increase your level, you find gradient. When you decrease the level, you find area under the ground. Are you able to appreciate all this concept. And by today, are you able to understand what's the meaning of acceleration? Okay, 10 meter per second square, what does it mean to you? It just means that every second, your speed increased by 10 meter per second. Is that clear? So I hope that you're able to appreciate the concept of this topic. Because once you appreciate, there's no need to remember anything. Okay, then the only thing to memorize for this topic is this formula. This is the only formula that if you want to memorize, it'll be this formula. Other than that, please understand. And once you understand, there's nothing else to remember. Okay, so did I make physics easy for you all now? If you like it, give me a yes reaction. If you don't like it, give me a no reaction. Okay, we have overtime by 15 minutes. So let me give you a checkout question. Hold on. Okay, actually, I just like to beside this formula, right? Another formula that you all need to know is average speed. Average speed is total distance over total time. Okay, and then you also need to know gradient and area under the graph, this concept. All right, so let's go into checkout question. Okay, number one, define acceleration. Okay, the definition and the formula. Okay, what is the definition of acceleration? What is the formula of acceleration? Okay, 3. One thing I learned today. Reading of today. Okay. How much I learned today. How will Mr. Chu teach today? Okay, once you answer the 5 questions, I call your name and you may leave the class. Okay, Yishen, you're number 2, right? Next time, can you give me the formula the formula, not to spell out. Okay, Yishen, you may go. Okay, very good. And also write down the A in front. Okay, Brian, number 1, okay. Brian, number 2, right? Give me your formula. And it's not current velocity, it's called final velocity. And then you put the bracket in your formula. Okay, Brian, you may go. Yishen, your formula, put a bracket. Okay, put a bracket. Okay, Ray Hong, next time can you try to give me your formula your formula in short form. Okay, in short form. Okay, Brian, well done. Yishen, well done. You may go. Okay, Ray Hong, you may go. Okay, Siren, how about you?
It's currently cloudy, 26 degrees.
Okay, Siren, just need to tell me rate of change of velocity, full stop. The rest no need. Then serial number 2, the V minus U put a bracket, because like that, then more correct. Is that clear? Okay, Ken. So hopefully it's helpful for you. Hey, you're learning Sec 3 stuff in Sec 2 that is it a bit too fast? Okay, see you again, Siren. Good night. Goodbye.